Kids, welcome to Sequencing and Patterns games. Let's do a quick review of what we see here in the game that we played in the class. All right, arithmetic sequencing formula. If you look over here, boom, it's AN equals A1 plus brackets N minus 1 times D. What does that even mean? All right, so if you look over here, this is the desired value that you're trying to achieve when they're asking you this. Here is going to be the first term in the sequence. Here is going to be the term you're trying to get to. So if they're trying to get to the 50th term, and so forth, that will be your n minus 1, and then this is what's called the common difference. It's basically just calculating the difference between the numbers, okay? So here's the first problem that you had in your quiz. It's the first term in the arithmetic sequence is 6, okay? So that's going to equate to our formula over here, which is going to be our first term, an, okay? So we just write a sub n on that, all right? There's a common difference, d is 3, and we're trying to find the 50th term. All right, so basically you just throw this in your formula. An is what we're trying to derive, so we keep that, and then we simply just write down your first term, which is 6. That's your a sub 1 plus, then we're going to put our brackets in here. You've got your n value. Your n value you're trying to get to is 50, right? Here, 50th term, and then we subtract 1 from that, so 50 minus 1, and then the common difference, it tells you it's 3. So you just take the numbers, you plug them into the formula, and then you just grind them out. 50 minus 1 is going to be 49, and the d is going to be 3 on that one. 49 times 3 is 147. 147 plus 6 from here is going to give you 153, and that's going to give you the red choice here. If you got that one wrong, it's just simply taking from your problem and throwing it into the formula. In the next problem, it says the first term in the sequence is 200. So remember the formula. The formula is an equals the first term, and we said the first term was 200 here. All right, so just simply write that down. Okay, and then we're going to add that to what we're trying to get to, the term here. It's 20, the 20th term, and then we're going to subtract that from 1, and then we're going to multiply that by the common difference. In this case, it's negative 10. All right, let's just go ahead and grind this out. Okay, so first thing, subtract that by 1. All right, so 20 minus 1 is 19. 19 times a negative 10. And that's going to give you negative 190. Negative 190. And now you've got 200 on the other end. So 200 plus a negative 190 is going to give you 10. And that's going to solve for what you're trying to get to. And that's going to give you the yellow answer, 10. All right, this problem is a teeny bit different. Tells us that the common difference is 10. We're given the 6th term, and that's 52, and we're trying to find 15. So remember the formula. It's a sub n equals a1 plus n minus 1 times the difference. Okay, common difference. So let's just start plugging our numbers in here. Whoa, wait a second. It tells us that the difference is the 6th term. There's a common difference, and it's the 6th term gives you 52, so you got to do a small calculation, and here's what I did. I said the 6th term equals 52. So the 5th term, since it's common difference of 10, would be 42. All right. 4th term is 32. 3rd term is 22. The 2nd term is 12. And the 1st term is 2. Because it's the common difference of 10, that means the 6th term is 10 more than the fifth term, which is 10 more than the fourth term. Okay, you with me so far? Now we have our first term is something we could plug into the formula right up here. All right, so we have an, and that equals our first term, which is 2, plus we're trying to get to the 15th term right here, minus 1. And then we already have the common difference, and that common difference is 10. Just simply plugging it into the formula up here. You see it? Take your numbers, plug it into the formula. So we've got 15 minus 1 is 14, times 10 is 140. All right? And then you're going to add your 2 right here. Combine that, 142. And that's going to give you the green answer down here, 142. All right, on to this next batch of problems here. It's the formula for the sum of consecutive integers. Sigma equals n times n plus 1 divided by 2. All right, so if the problem asks you here, find the sum of all integers 1 through 50. You just basically take 50, throw it in here, throw it in here, 50 times 50 plus 1 divided by 2, plug and chug. 50 times 51 divided by 2 gives you 1,275. Let's take a look at that problem. Once you have the formula, this pretty easy problem, once again, the formula is sigma equals n times n plus 1 divided by 2. N is where you're trying to get to, all right? So we're trying to get to 1,000, so it's 1,000 times 1,000 plus 1 is going to give you 1,001. And then you're going to divide that by 2. When you plug and chug, you're going to get the right answer here on your calculator, which is going to be the yellow 500,500. Formula for the sum of just even or just odd integers. N times n plus 1. From the formula here, you just simply plug in your numbers. The problem you looked at over here is find the sum of even integers to 50. It's 50, that's your n value here, that goes there. And then this is your value here. So it's 50 times 50 plus 1, or 50 times 51. Plug and chug, 50 times 51 gives you the blue answer, 2,550. In the final problem, find the 7th term in the sequence. Just think of algebra. So here's our terms in the sequence, 1, 2, 3, 4, 2, 6, 18, 54. So let's start with the first term. The first term is 2, and if we multiply by x, 2 times x, that's going to give us the next term in the sequence. 2 times x equals 6. So a quick calculation, you see here our x value is going to be 3 because 2 times 3 equals 6. Now we go to the next term. The next term is 6, and if we say 6 times x, that's going to equal the term that's next, which is 18. Let's spot check our work. If we throw in 3, which we said was our x value, 3 times 6, does that equal 18? Yep. So there you have it. That's the first term. The second term, we just spot checked our work. You see that we've got 1, 2, 3, 4 terms. So 54 is our fourth term. We're trying to get up to 7. So let's just go over here and say 54 times our x value, or x is 3. We're going to see that 54 times 3 is going to give us 162. All right? And 162 would be our fifth term. Okay? Now our sixth term would be 162 times what we said was the difference in the sequence. That sequence is 3. So 162 times 3 is 486 for the 6th term. We're trying to get to the 7th term. So now we go 486 times 3 to get to the final 7th term, and 486 times 3 is 1,458, and that will lead us to the answer in the yellow, 1458. Kids, thanks for watching. The thing I want you to make sure that you see here at the bottom, if you have questions, you absolutely have to ask for help. We can't read your minds. If you're struggling, please ask. There's so many different ways for us to get you the information. You can ask me, Professor Thomas. You can go into one of the rooms with the assistant. Any one of those kids can help you. We've got video tutorials. If it's math, it's online on our Quantum site. There's math videos, there's Review It, there's Learn It, there's everything on of our 2 websites, asktheprofessor.org and Quantum site. Kids, thanks for watching the Kahoot game for geometric sequencing and arithmetic sequencing. Bye for now.